Hello everyone, this is Bsc second year real analysis first class. So today I am going to discuss one new concept, that is real sequences. Real sequences. Sequence is some different function. Sequence is a function from set of natural numbers to real number. So today we are going to discuss one new function whose domain is fixed, whose domain is set of natural number and codomain is a set of real numbers. If codomain is a set of real number, then we can say that this sequence is a real sequence, and if codomain is the set of complex numbers, then it is a complex sequence. But in real, we are discussing only real sequences. So definition of a real sequence. A function f whose domain is set of natural numbers and codomain is set of real numbers is called real sequence. Is called real sequence. So sequence is a function f from here to r. So sequence whose domain is fixed and which is a set of natural numbers. Therefore, every sequence is denoted like this. So, element of the sequence S1, S2, S3, and so on. So, elements of the sequence, that is the first element of the sequence is S1, second element of the sequence is S2, third element of the sequence is S3, and so on. So, this is the definition of a real sequence, which says that a function f whose domain is the set of natural numbers and codomain is the set of real numbers is called a real sequence, and it is a function from set of natural number to real numbers, and sequence is denoted like this. So sequence contains always an infinite number of elements. Sequence has infinite number of elements. If it is a repeating element, for example, if it may be a repeating element 2, 2, dot, 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 dot. So this sequence contains infinite number of elements, and if two digits of the sequence are same, but we treat S1 2, S3 2, they are a distinct element. Sequence मध्ये जरी आता 2 किती दा रिपीट झाला इन्फिनिट वेळेस, पण प्रत्येक संख्येला S1 ला आपण एक वेगळा नंबर ट्रीट करणार आहोत, S2 हा एक वेगळा नंबर ट्रीट करणार आहोत, S3 हा एक वेगळा नंबर ट्रीट करणार आहोत. त्याच्यामुळे सीक्वेन्स कंटेन्स इन्फिनिट नंबर ऑफ एलिमेंट्स. Now examples of the sequences. Example first, the sequence Sn 1 by n. N belongs to set of natural numbers. So 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. So this sequence contains infinite number of elements. So second example, n. 1, 2, 3, 4, 5, and so on. So this sequence is a set of natural numbers. So this sequence contains infinite number of elements. So S1 is 1, S2 is 2, S3 is 3, S4 is 4, and S5 is 5. Now third, minus 1 raised to n. So this sequence minus 1, 1, minus 1, 1, minus 1, 1, and so on. So this sequence contains infinite number of elements, and these elements are repeating elements, minus 1 and 1. Now the range of the sequence. Definition. The range of the sequence. Definition. The set of all distinct elements in the sequence, is called range of the sequence. It's called range of the So range of the sequence is set of all distinct elements in the sequence. Now the range of the sequence is sequence itself, and it contains infinite number of elements. Now the range of the sequence is sequence itself. It contains infinite number of elements. Now observe the example third. The range of this sequence is 1, minus 1, which contains only 2 elements, and the range of this sequence is finite. The range of the sequence is what? The collection of all elements of the sequence which are distinct. Now, in the sequence C, there are only 2 elements which are distinct, and these 2 elements are repeating in the sequence. Hence, the range of the sequence is this. So, from this we can write range of the sequence may be finite or infinite. Finite or infinite. Range of the sequence may be finite or infinite. Now consider a sequence and find its range. Now the sequence SL is 1, 1, 1, 1, and so on. The sequence SL, second sequence 1, 2, 3, 1, 2, 3, 1, 2, 3. Now third sequence. Third sequence 1, 2, 1, 2, 1, 2, and so on. Now, range of the first sequence is only one element which contains 1. The range of the sequence is second sequence 1, 2, 3, and the range of the third sequence is 1, Now bounds of a sequence. Bounds of a sequence. First, bounded above sequence. A sequence SN definition. A sequence SN is said to be bounded above. It's said to be bounded above if there exists K belongs to R such that Sn is less than or equal to K for all n belongs to. If there exists a real number K in set of real numbers such that every element of Sn is less than or equal to K, then we say that the sequence is bounded above. For example, Sn 1, minus 1, 1, minus 1, and so on. Now this sequence is bounded above, and upper bound of the sequence is 1. That is, every element of the sequence is less than or equal to 1. Sn is less than or equal to 1. So upper bound of this sequence exists and it is equal to 1. Therefore, this sequence is bounded above. Now bounded below sequence. Bounded below. A sequence Sn is said to be bounded below if there exists some small k belongs to R such that every element of the sequence is greater than or equal to k. A sequence is said to be bounded below if there exists some small k in set of real numbers such that every element of the sequence is greater than or equal to k. For example, Sn 1 minus 1, 1 minus 1 and so on. Now this sequence is bounded below and lower bound of this sequence is minus 1 because every element of Sn is greater than or equal to minus 1. Now bounded sequence. Bounded sequence. A sequence Sn is said to be bounded if it is both bounded above and bounded below. A sequence is said to be bounded if it is both bounded above and bounded below. That is, there exists some small k and capital K in I such that every element of Sn is greater than or equal to small k and less than or equal to capital K. A sequence is said to be bounded if there exists some small k and capital K in R, that is, small k and capital K are the real numbers, such that every element of Sn is greater than or equal to small k and less than or equal to capital K. Now, example, a sequence 1 minus 1, 1 minus 1 and so on. Now, small k, that is lower bound of the sequence is minus 1 and upper bound of the sequence is 1. So, every element of sequence is greater than or equal to small minus 1 and less than or equal to plus 1. Hence, this sequence is bounded. Now, consider the sequence 1, 2, 3, 4 and so on. Now, this sequence is bounded below but not bounded above. Lower bound of the sequence is 1 and upper bound of the sequence does not exist. Hence, this sequence is bounded below but not bounded above. Now, consider dot 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 minus 3, minus 2, 1, comma 0. Now, this sequence is bounded above and the upper bound of the sequence is 0 but lower bound of the sequence does not exist. Hence, sequence may be bounded above, may be bounded below, may not be bounded above, may not be bounded below, may be bounded, may be unbounded. So, lower bound does not exist, upper bound of the sequence is 0. So today I am going to stop this lecture here.